Welcome to today's webinar. On behalf of the entire Dlubal team, I wish you a healthy and successful new year. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, the webinars, technical content of the website, newsletters, and so on. I will be the moderator today, and Clemens Gutmann will be the presenter. And the topic today is wind simulation with RWIND 3 and RFEM 6. Clemens will be the presenter, as I already said. He works in the customer support team, and he is also in the product engineering team. And for example, is he responsible for the program RWIND. Okay. For the attendees who participate the first time, I say something how you can ask questions. At first, I switch off my camera that you can see the full screen. Just press that button with the question mark, then enter your question in that field, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Clemens. Clemens, it's your turn.
Thank you, Andreas, for your introductory words. I also want to welcome you to today's webinar. Today we are going to look at 4 different topics. At first, I want to give you a quick overview over the latest development features that we've implemented into RFEM 6 and RWIND 3. Then I want to point out a very specific highlight of these new features, and that is the online licensing possibility and cloud calculation capabilities of now RWIND 3. And in the third chapter, we are going to perform a wind analysis in RFEM 6 together with RWIND 3. And last but not least, I want to share with you a quick outlook about what's to come in the next few months. The first feature that I want to show you is the consideration of initial states. So RWIND 3 now considers automatically initial states if they are present in RFEM 6. So whenever you are calculating a load case or a load combination that has a assigned initial state, then the initial state will be calculated first, and then this geometry is taken over to RWIND 3, and then the wind analysis is performed with this initial state geometry. This is especially important and necessary for membrane structures. So this is now possible. Then you have now the possibility to create to average results over time when doing a transient flow analysis. This is a feature that is currently only available in RWIND 3, but not in RFEM 6. So whenever you need that, you have to go into RWIND 3 and change or select that option there. The third new feature is the clipping box for flow field results. So I want to show you this directly in RFEM. Up until now, it was possible to display the flow field results in a clipping plane, and the clipping plane automatically had the size of the wind tunnel. And now we implemented a clipping box into RFEM 6. So you can reduce the size of that clipping plane to what's actually mostly needed. So usually you want to know the quantities around the structure and not like for the whole wind tunnel that is only needed for the calculation. And this is now possible if you activate that checkbox over here. And if you click the radio button, then you can drag the clipping box to the size that you want, and then switch back to the clipping plane, so you can manipulate the clipping plane as you need it. We then implemented the possibility to display the pressure and pressure coefficients on the original model. So up until now, it was only possible to display the results on the computational model that came from RWIND 3. But now you can also inspect the results projected on the original model. I also want to show you how that looks like in RFEM 6 itself. So if you have the pressure or the pressure coefficients selected here in the result navigator, then you have a new possibility for the display down here. So this was possible before. So you have the computational model from RWIND 3 and the results displayed on it, but now you can switch to the original model and you see the mesh and structure of the original RFEM 6 model and inspect the results on the original model too. And the last new feature is the possibility to close hollow sections. This is a new default setting that can be changed in the mesh settings in RFEM 6. I'm going to show you this in a second. So usually, like with this membrane structure, you don't want to go you don't want the wind to go into the hollow section, because usually you have a detail there that connects all the elements together. But of course, it's also possible to if you have bigger hollow sections, to open them up, but usually it's not wanted. And there's this setting I'm going to show you. You go on the mesh settings, wind simulation, and now you have here a check that says that that only the external surfaces for hollow sections shall be used, and that also means that they are capped at the start and at the end. Let's come to the biggest new feature from the last months. So as you know, we released RWIND 3 last summer, and the most important difference or new feature is the online licensing. The online licensing you already know from RFEM 6, Stab 9, and our section 1, that has all the advantages of coming with the online license, and that these advantages we now brought to RWIND 3 as well. So you can switch between the online license and the software key. So it is still possible to authenticate the software with or authorize the software with a software key, but the online license has a specific advantage to that, because it makes cloud calculation possible. So cloud calculation, you already might know that we have this feature implemented into RFEM 6, where you can send your model to the cloud, have it calculated there, and then after the calculation has finished, you can download it from there and analyze the results and the model further. And up until now, it wasn't possible to analyze models that had a wind simulation load cases active. And this is now possible if you switch to the online license. And this leaves you with several advantages. So the first advantage is, if you do wind simulation, you know that it takes some time and also uses a lot of CPU, or all the CPU that is available, and therefore somewhat blocks your computer from doing other work. And by using the cloud calculation, you can avoid that, and the cloud does all the hard work, and you can keep on with your other tasks and continue your work with a model once it has finished calculating. Furthermore, you have the possibility, you don't block your license. So whenever you send the model to the cloud, you have your license and RFEM free to use for another project, or a colleague can use the license. So this is another big advantage of the cloud calculation. And to show you how simple that works, I am going to delete all the results and send this small model to the cloud. So I go here where you usually click Calculate All. I select Cloud, Calculate in Cloud. And now a new dialog opens up where I can select the different servers that are available, and then I can check whether I want a notification once the calculation started and or it has completed. And then I click Calculate in Cloud. The model is transferred to a server, and then I can track the calculations here in my extranet, which is also available in the Dlubal Center. I go to API and Cloud, and then I can see the task that I just sent. I have some recent cloud calculations, and they can inspect some details, and also have a download link. I'm going to show you later on, once the calculation is finished, how to proceed then. Okay, I will now proceed to chapter number 3, where I want to perform a wind analysis together with you. And for that, I'm going to create a new model. I have a research building, and I don't need any solids today. I want to use the building model add-on as well as the wind simulation add-on. I leave the standards as they are, and I want to show, that the Z axis shows upwards. Then there's a small new feature that I will show you as well, which is a north arrow that comes quite in handy for the documentation. I then want to pick a location that is especially handy for all the wind simulation, because automatically you get the right coefficients and like the parameters from your from the code that. Okay, today I am here in Baden-Württemberg. My building is going to be constructed here, and now you can see the location automatically gets transferred, and also the load zone data is downloaded and will be available in the load wizards later on. The last thing I want to change here is the terrain. Since we have a subterranean level, and this terrain will be transferred as the base plane for the wind simulation, so that the subterranean plane level is not considered for the wind simulation. That's why I check this here. I click OK. Good. I then want to model by using a background layer. It's going to be a DXF file. Okay. and I want to place that DXF file in that bottom left corner, and I can do that by using that button, the right button here. All right. The next thing I'm going to do, I'm going to set up my building model, and I'm going to create new building stories for that. So I have my subterranean level that is below 0 and has a height of 5 meters. The next will be the ground floor with 6 meters. And then I have 3 more stories with 4 meters. Yeah, that's everything for this. I then create my first material. That is going to be a C2530. Okay. And the columns in my building have a cross-section, circular cross-section with 300 millimeters. Have thicknesses for the walls and slabs of 24 centimeters, and for the base we have 35 centimeters. Okay, if you are using the building model, you have some great modeling capabilities that can be found here. And here you can model columns, walls, floors, and openings, and not only one, but like for every story individually or all together, what you select. So let's start with the floors. So I have a polygonal floor with these settings. They are fine. And then I'm going to just pick, sorry, I forgot. And here in this drop-down menu, you can choose which building stories are considered by this modeling. So I want to, every story has a floor. And if I now pick all the corners, and tilt the view a little bit, you can see that, this floor has been created in every story. All right. The next thing I want to do is to create a rectangular floor opening, but not in the top floor. And that one is going to be here. And there. Double check. Looks good. I then want to create my basement. Therefore, I take the top floor, create a copy, and I have to add 5 more meters. Okay. And then switch the thickness to 35 millimeters. And I think I made a mistake here. Forgot 1 digit. All right. Good. So, by the way, this brownish thing is this terrain. So that what we checked in the base data. Then we have our walls. And the walls I'm going to create the same way. So I'm selecting wall. Settings are fine. And then create the walls. Oh, forgot the top floor. Can just copy that by 4 meters. And everything is okay. Good. Then we have the concrete floor, concrete walls done. And the rest of the building has a glass facade that I want to, of course, consider for the wind simulation, but I don't want to include it into the static analysis. This will be done later on, and that's why I'm going to use a special surface stiffness type, and that is going to be the load transfer surface. So the load transfer surface is a stiffless surface that only transfers the load to adjacent real objects. So the walls and slabs, for example, or other objects. And I'm selecting the Y stripes here. So only in the Y direction of that surface, the load is being transferred. So like in one direction only. Okay. And now I want to select all stories but the sublevel one. And then I can, again, model this very quickly. All right, that looks good. And now for the last one, to cancel that, to change the parameters. And then one last time. All right. And the last thing that we need are the columns. For them, I will use a beam with member hinges at the end and at the start. Okay. All stories. And then just place them. And we are done. So yeah, that you can see how quickly it goes, how to model such a building. Of course, it's quite regular over the stories, but even if you have different stories, like different layouts, you can pick the stories that are similar and then model quickly the objects in the different stories, and the program automatically takes care of the correct height of the walls and dimension of the floors and so on. We then need a support of the base, new surface support, and for that I'm going to use these values. They are just made up. I want to assign this to the base. Okay. Then we can proceed to the loading, and to facilitate that process, I'm going to create some object selections. So I want an object selection for all my surfaces that are parallel to any floor, so that are horizontal. And I can do that by picking this option, parallel to surface, and pick an example surface, and that is going to be the top floor. And now all surfaces that are parallel to that one are selected. And the second will be, no, we don't need any second. We can just flip that around. By using this. And now we have all the columns and all the walls. Good. All right. Then to the load cases. I want to create a new load case for the in-post load. Another one for the snow load. And the wind loads are then generated automatically later on when we use the load wizard for the wind simulation. All right. Then we have some additional self-weight on our floors. Of 1 kilonewton per square meter. And a imposed load of 2 kilonewtons per square meter. And then finally a snow load in the area where the building is constructed. It is almost 2 kilonewtons per square meter that you can retrieve from the GeoZone tool on our website. And this is only assigned to the top floor and of course to the right load case. Okay. Then quickly want to change those settings. For now, they are fine. Almost, sorry. Okay. And then we can proceed to create the wind profile and then the wind simulation. So by default, the wind profile is generated by using the according standard. In our case, it's the Eurocode 1. And by default, the structure height and all the other settings are taken over to the for creating this wind profile. The only thing that we have to still choose is the category, and since this is at the edge of a town, it is going to be category 3. And this is everything that you have to do here. And then we can create a new wind simulation with those settings that we just made. And I want a uniform wind direction, but with a larger step angle of 90 degrees. And the program automatically then generates those according load cases. We hit OK. Looks good. Then let's check one last time the combinatorics. That's also looking very good. And now we can calculate this model. Since we have several wind load cases, it would take too long for this webinar, but I could send it to the cloud now and calculate it in the cloud and then proceed further. I have done that earlier today, and I want to open the model with the results and then share them, analyze them further. All right. So now we can take a look at the results of our wind simulation. And we can here now inspect the pressure, the wind pressures, and also the pressure coefficients, as well as the flow field quantities, whatever we want to know in the different directions that we analyzed, and now can get a better idea of how the building reacts to wind exposure. And as you can see, the terrain that we set in the beginning is now displayed, it's also displayed, but the walls beneath the terrain are not affected by the wind. And now I can show you one last thing. You can see the north arrow. By default, it's deactivated, but you can activate it here in the display navigator. I think this is a quite handy feature for all, if you want to document how the orientation of your building is. And you can, of course, print that to the printout report. One other thing that I want to show you is something that I forgot to model earlier on, but I did with this model. So with the building model, you can create shear walls that are usual for the bracing of a building, and those shear walls also have results. So you can now see, when using these vertical result lines, this is for the whole building. This hasn't something to do with the shear walls. So you have deformations and also generally the forces that the wind creates. So for example, if we display the wind tunnel, so the wind comes from the left, you can now see how big the impact of the wind is on the general building. But if you select, for example, the members, these shear walls are result members actually. And for example, here the VZ value, and make the building transparent. Then you can see for every shear wall how the forces distribute over the several shear walls in the several directions, and then design design those shear walls accordingly. Then let's go back to the first model that I've shown you, and I have received a notification that it has calculated, like the calculation has been completed, and there's an email that looks roundabout like this. You can see how long it took, how many credits it costed, and you get a download link that is also, of course, available in the Dlubal Center. If you go to API and Cloud, I can now download this calculation to my PC. Okay. And then open this one again. And we can see that all the results are there, and we can now proceed with our analysis and the design tasks that we have to do. So it's that intuitive and simple to use. Okay. Then to the last part of today's webinar, the outlook on the upcoming features. So we are currently working on program enhancements to meet the requirements of the WTG Code of Practice number M3. This is a German club that is dedicated to wind analysis and simulation. And this will include time-varying wind speeds. So up until now, you only can define one constant wind speed, but in the future, we will be able to vary these wind speeds over time. The second thing we are working on is to bring more our wind results directly into RFEM, so you don't have to leave for inspecting results to our wind. So we want to bring every result that is available in our wind also to RFEM 6. Then we have the plan or working on bringing the partial results from the transient flow calculation to RFEM 6, and that includes first the display and then also the usage of those single time steps in a static analysis later on, or dynamic analysis. This is quite a big thing, so will take some time, but we are working on that. And last but not least, we have want to implement result combinations for several wind simulation load cases. So if you have created or calculated multiple directions, multiple wind directions, and have several load cases, and you just want to know, okay, what are the biggest pressures and biggest suction loads, then you can create a result combination for those load cases, especially for these wind simulation load cases. So that's everything from me today. I want to thank you for your attention and give back to Andreas.
Thank you, Clemens, for your presentation. I would like to invite you to visit our booth on the BAU in Munich next week. I will be there as well. My colleagues and I will show you new features in our programs and the add-ons. You are welcome. Okay, that's also all from my side. I thank you for your attention. Thanks to Clemens again for the presentation. I wish all a nice rest of the day. Bye-bye.